Hello, everyone. I'd like to welcome everybody to today's webinar. We have Decarbonizing the Built Environment, Getting It Right. I am Marcy Weber, and I will be your education team moderator for today's presentation. Today's webinar is going to run 1 hour. Today's speaker is our new Vice President of Markets and Sustainability, Rachel Jamison. And note that this course is approved by the American Institute of Architects. If you belong to this organization and wish for us to report your credits, email us with your member number after the webinar. Please note that this presentation is copyrighted. And note that this webinar and associated slides should not be used as a substitute for competent engineering support and expertise. Here's the course description. Hopefully you've already read that and know what we're talking about today. So I'm not going to sit here and read this to you. Also, same thing. Here are the learning objectives. Hopefully you've read them, know that what we're going to be covering today. And here is our presenter for today, Rachel Jamison, and your production team, Lori Cook, our Director of Educational Outreach. Myself, Marcy Weber, and Kim Paulson are working behind the scenes to hopefully make everything run smoothly for you today. And without further ado, I'm going to send you over to Rachel to talk about decarbonizing the built environment.
Good afternoon, everyone. I hope you can see my screen. I am delighted to be here presenting on decarbonizing the built environment on Earth Day week. A lot of Earth Day presentations tend to be a bit weighted in the doom and gloom side of the spectrum. I am delighted to be here today to talk about a tremendous opportunity that we in the building trades and professions have in front of us with climate change. I'm going to really talk about data-driven solutions. When we look at the challenges posed by climate change specific to our sector, what we see is that ultimately, while right now we play a big role in the problem, we can play a tremendous role in the solution. A few stats to start us off. The building industry is responsible for roughly 40% of all energy-related greenhouse gas emissions every year. To reach net zero by 2050, we need to reduce our emissions by at least 50%. If we don't make changes that are significant and data-driven now, and continue in the trajectory that we're on, we're looking at an increase of 50% by 2050. Right now really is our opportunity to get it right. The US, as many of you already know, has also set some very aggressive climate goals. By 2030, the aim is to reduce emissions by approximately 50% below a 2005 baseline, and as was mentioned previously, reach net zero emissions by 2050. What isn't often talked about, where a large opportunity for building materials lies, is an intent by the federal government to not only reduce emissions, but to also scale up CO2 removal strategies. What if, and I'll pose this at the beginning, our built environment became a carbon storage, functioned as a carbon storage unit, as well as a place to live, work, eat, play, etc. Embodied carbon in many ways really is the regulatory challenge, both of the present and the future. What are we talking about when we talk about embodied carbon? Embodied carbon is the carbon dioxide or greenhouse gas emissions associated with the manufacture and use of a product or service. For construction products, this means the CO2 or greenhouse gas emissions associated with extraction, taking a piece of material from the earth, moving it to a manufacturing facility, making it into the thing, moving it out of the transportation, out of the manufacturing facility, into the building and finally into the building itself. And ultimately, in some cases, looking at the end of life. There isn't at this point global acceptance for a common method for dealing with embodied carbon. Lots of standard setting bodies and policymakers are currently looking at how to, through standards and policy and regulation, get their head around this in a manner that reduces embodied carbon drastically enough to meet the goals that we just talked about. Up on the screen are several of the standard setting bodies that are currently looking at this. ISO has multiple existing and in-process standards that look at embodied carbon. I'll dive into one of those shortly. ASTM is looking at how to standardize carbon reductions in specific building materials. ASHRAE, through its green building standard, is looking at how embodied carbon can be addressed, and green building standards that we're all familiar with, Green Globes, LEED, Living Building, they're all also looking at ways to formalize and standardize reduction of embodied carbon, both in the building and in building materials. What we don't have yet is a common way to do that everyone agrees on. Architects and designers too are being required by their project owners to reduce the embodied carbon in their projects. Some public buildings, some private buildings, they are creating their own tools. So in essence, and those tools are not necessarily harmonic either. In a lot of ways, we are in the Wild West of embodied carbon standardization and integration into building design and specification. The Wild West, while wild, is also a humongous opportunity for us to get it right. And that's really where I'm going to focus on today, is how can we leverage policy to get management of embodied carbon right holistically. Let's start with where we are. A lot of jurisdictions, including the federal government, are looking at a buy clean approach to reducing embodied emissions. Buy clean policies require specification of best performing materials within the same material category based on an EPD, an environmental product declaration. What is an environmental product declaration? It's defined by ISO 14025 as a Type 3 declaration that quantifies environmental information on the life cycle of a product. ISO 21930 provides requirements for developing an EPD specific for construction materials. Below is the graphic that talks about the different life stages and the associated emissions per ISO 21930. Essentially, an EPD is based on a product category and is based on a product category rule that defines for this product, we're going to look at, and you're pulling the stages from this graphic, what stages you're going to look at. So these really go back to what I had talked about previously, from extraction, transport, manufacturing, and then during construction, and also use. EPDs are an excellent tool for looking at materials' environmental impacts. The pros of an EPD or a buy clean approach. You're going to get the best of the worst. With a focus only on materials that are already carbon intensive, many buy clean programs only focus on particular materials. So any other materials that already have low embodied carbon aren't necessarily part of the conversation. So you are going to get the best of the worst, and it is important that all materials, whether they're low in embodied carbon now or not, are working to get better. Cons. Already climate smart materials aren't engaged in discussions, nor are they required to be specified. So essentially, by not being in the conversation, they're overlooked. EPDs are not consistent. Within product categories, they're not consistently developed. So going back to that previous slide, an entity can select what stages of a life cycle are included in the EPD. They don't have to be the same. So when you're comparing EPDs to one another, you aren't necessarily getting an apples to apples perspective. This is the big one. This buy clean strategy doesn't consider stored carbon capacity of some building materials. Take wood products, for example. 50% of wood by weight is stored carbon that's been sequestered from the atmosphere. When you are building with wood products and the carbon that was stored is kept in the building for the life of the building and beyond if the building materials are reused. And finally, one of the challenges with a buy clean approach is that they tend to be limited in scope, primarily focused on infrastructure projects, and not always consistently focused on the built environment as well. It's a graphic that points to what you get with the EPD model and starts to whisper to what we're going to talk about next, which is a whole building LCA model. In the EPD model, you have the best of a material A. Let's say A is, I don't want to use specific materials, but what you can see here is you have 4 different versions of material A. In the buy clean or EPD model, you would specify material A2. In that product category, it is indeed the best product from the standpoint of embodied carbon. What it doesn't do, however, is look at comparable materials from the standpoint of use and application in the building, and then say, if we start to compare a number of products that serve the same purpose, what product is going to be best? And that's where we get into whole building life cycle assessment. So the alternative to a buy clean is whole building life cycle assessment. It's a stepwise approach to reducing embodied carbon in building projects, wherein the first step is to require whole building life cycle assessment at the design phase. Therefore, you're getting the best material, I'll go back to this slide, that serves the same function, rather than simply a material that is best within its product category. You're getting the absolute best material from the standpoint of embodied carbon. Step 2 then is based on whole building LCA. You can require specification of best performing materials based on EPDs. But without that first step, you're not necessarily specifying the material that's going to result in the maximization of embodied carbon reduction. And that's really where the heart of this opportunity lies. What is whole building life cycle assessment? Athena Institute, based in Canada, defines it as an LCA exercise where the entire building project is considered holistically to help building designers focus their efforts when a reduced footprint is desired. LCA is often applied to core and shell. There's a recognition when whole building life cycle assessment is applied that finishes within the buildings are often replaced during the lifetime of the building. Hopefully buildings are being designed for longevity, and therefore that core and shell isn't necessarily being replaced, and is often where the focus again of that whole building assessment is. So what are the pros and cons of a whole building life cycle approach? So the pro, as I've alluded to, is decarbonization is maximized in the building project itself, not just within a material category. And thus decarbonization is maximized holistically in the built environment as materials are compared to one another as opposed to simply compared to themselves. Another pro in a build clean or a whole building life cycle approach is that preference can also be given to products that both sequester and store carbon. It's one thing to reduce emissions, and i.e. reduce the miles driven, reduce the energy consumption at the manufacturing site, etc. It's a whole nother level of climate innovation to have materials that store carbon. Again, using wood products as an example, the innovation that wood products use is actually older than all of us, and that is called photosynthesis. The innovation, photosynthesis, is what essentially pulls that CO2 from the atmosphere, sequesters it into the wood product, which then stores it into for the life of the building. Similar cons, quite frankly, to the EPD model. There's currently a lack of consistent methodology for conducting whole building life cycle assessments. I'll get more into some tools here shortly, but you're not guaranteed the same outcome depending, if you put the same inputs into 2 different whole building LCA tools, you're not guaranteed the same outputs. The second con is a lack of baseline data to which new projects can be measured against. Essentially, if we're going to set goals on holistically reducing carbon in the built environment, we need to make sure that we are being thoughtful and data-driven in how we are doing that. Thus, that baseline data is critical to say, here is a standard comp of, let's say, an office building built to high energy efficiency standards in 2015 or 2012, or, we can policymakers can think about what year makes sense, and then set that whole building threshold against the baselines that will ultimately be established. Again, right now, we don't have that baseline. So what are the building blocks to getting to maximized decarbonization and a whole building life cycle assessment approach? I'm going to dive into each of these, but the first is data. You have to have data that is publicly available, data that does not have any proprietary applications overlaid to it. That transparency is key so that the built environment holistically can move forward with that data. And that gets into both EPD data as well as a library of buildings, which is that benchmark data I spoke about in the last slide. Benchmarking essentially the environmental footprints of existing buildings. The next are rules of the game. So what you heard both in the cons of EPD and the cons of whole building life cycle assessment approach to decarbonizing buildings was a lack of consistency. Policymakers have an opportunity to create the bounds within which those assessments operate so that you do get, regardless of the tool, the same output. What data needs to go in and what data needs to come out on the other side so that you have that capacity for apples to apples comparison, regardless of the tools that you use to run your analysis. Then you get into the whole building life cycle approach and the subsequent procurement policies. So in many ways, when we're looking at buy clean or these decarbonization policies that are being proposed, we are missing a significant foundation of data and rules of the game. So again, it kind of it magnifies the Wild West approach we talked about earlier. But if you were to do this in a stepwise way and take the time to make sure that we get it right, that we would start again with the data collection, the library of buildings, the rules of the game, and then that policy approach. And finally, demonstration projects. We need to make sure that the policy decisions that we're making are proving themselves out in the built environment, and we're able to tweak and work with industry in ways that encourage that the overall carbon reduction goals are met. I'm going to dive into each of these now. So the policy roadmap to whole building life cycle assessment. Fully fund public data repositories and initiatives. Require public access to data and data consistency. Develop industry-wide rules of the game. Require whole building life cycle assessment for public projects, and fund demonstration projects. And I am going to deep dive into each of these. Fund public data repositories and initiatives. The federal government has already invested in a publicly accessible repository for LCA data. It's called the LCA Commons. It is critically important from a policy standpoint that the tools that are on the market conducting whole building life cycle assessments are pulling from a publicly accessible data set. Climate change is something, unfortunately, that we all share, that we share a need to address together. That data, that foundational data, needs to be publicly available and free to be used by any entity that may want to use it. LCA Commons is currently being led through an MOU among Department of Energy, the USDA, and Department of Transportation. From a policy standpoint, really identifying a champion, perhaps Department of Energy, to convene and work with entities, public and private sector, on collecting the data and really making the LCA Commons the repository for all of the LCA data that individual manufacturers and sectors are currently collecting. Second is a library of public buildings. GSA at the federal level manages a significant number and owns a significant portfolio of buildings. This is an easy way for all of us working in the built environment to use public data to set the benchmarks that we talked about previously. Essentially, let's work together with GSA or other federal agencies to use their existing buildings as benchmarks. And then from there, policymakers are able to, with good data and good information, set policy goals. For example, that a future office building must have 30% or 20% less embodied carbon than its comp. There's also then the opportunity from this library of buildings to get a sense for, are existing buildings storing any carbon? And do we want to set any goals for carbon storage in future publicly funded buildings? So that's building block one. Next, and I alluded to this previously, is to require public access to data to ensure data consistency. It's going to be important from a policy level that whole building life cycle assessment tools use publicly available data that are pulled from public repositories. There is a growing market for IT tools that conduct various levels of whole building LCA that also look comparably at different EPDs at a material level that architects and engineers are using currently. AWC supports and is excited about this market. It's important, however, to ensure that the data the tools are using are consistent in order to ensure that outputs are consistent. Again, getting back to that apples to apples. From the standpoint of the market, we don't want to force or compel a user only to use one system in order to get like comparisons. We want to be able, through data accuracy and public accessibility, to be able to compare outputs from different systems, whole building LCA tools. That's critical. Requiring that the tools sourced from the LCA Commons is one method that at AWC we support of promoting more consistency among platform outputs. We're not going to get into individual platforms today. From AWC's standpoint, we really do see the value in a growing market for these tools. Again, it's imperative from a policy standpoint that the tools are utilizing data that is publicly accessible and consistent. Next, rules of the game. While a lot of the tools on the market are claiming to comply with ISO standards, and I believe they are, as we've discussed already, they don't produce matching results. As the largest building owner in the world, the federal government has a role to play and, quite frankly, an enormous opportunity to establish rules of the game for whole building life cycle assessments as applied to federally funded projects. These rules of the game will help ensure that apples to apples comparisons are possible between different platforms that design teams are using, and essentially level the playing field so that architects and engineers are able to, again, plug into whatever system they're using and know that the boundaries of their assessment are contained. Build clean. Adopt policies requiring whole building LCA at the design phase of a building project. The other steps are complete. The data is harmonized. There's public access guaranteed. Baseline whole building LCAs have been established. Build clean policies are really where you're going to see the bulk of capacity for decarbonization of the built environment. Policies that require that all buildings receiving public funding must be designed to contain X% lower embodied carbon than their traditionally constructed comp, as per the Library of Buildings established by GSA that we talked about earlier. This is where you start to see significant reductions in the built environment holistically. In addition to setting reduced embodied carbon thresholds, Build Clean legislation should incentivize the specification of materials that not only are lower in embodied carbon as compared to one another, not just themselves, but that also store carbon. This is where, again, on this Earth Day in 2022, we have an opportunity for the built environment to not be what it has been historically, which is really a source of emissions and a source of challenge from the standpoint of climate change, but really one of the most innovative solutions. That development won't work at odds with climate solutions, but that development can actually be a climate solution through specifications of, again, these low embodied carbon, high stored carbon materials. And finally, it's important to fund demonstration projects. Department of Defense, low-income housing, USDA, GSA. The federal government, again, is a massive investor in the built environment. What do demonstration projects do? One, they prove the benefit of whole building life cycle assessment for reducing embodied emissions. We need to have the data. So it proves out the concept, proof of concept. Two, it demonstrates the benefits of specifying materials that store carbon. We can start to create numbers behind the assertion that carbon is stored and actually get real numbers behind it. And finally, help to build the intellectual infrastructure within agency contracting departments. A lot of contracts for buildings are kind of rote. They're moved through, kind of one after another. By requiring whole building life cycle assessment, we help to break some of the barriers in contracting departments within agencies so that they can start to think outside of the box from the standpoint of carbon, climate, and how their project may be of benefit to the climate. So we're back to this slide, the impact of the EPD model versus the impact of the whole building LCA model. Whole building LCA gives you the best project from the standpoint of carbon reduction. EPD gives you the best product. Right now, from a policy standpoint, we've put the cart before the horse. Rather than looking at the best project first, we focused on looking at the best product. Both are critical. However, applying whole building life cycle assessment as your first stop is how you're going to then be able to get the best, not just the best of the worst, but the best of the best from the standpoint of the products that you specify for your project. And thus, you're maximizing those reductions that are imperative. Our vision is that the built environment, as I've mentioned earlier, is actually a climate solution. That cities become carbon sinks. That material choices support renewable resources and rural economies. That buildings are designed for deconstruction and components can be reused. What if we could take the entire discussion of end of life off the table and design to be deconstructed? And finally, the vision is that data is front and center of policy development. We have the opportunity to get this right. We have the opportunity to do the math right. There's been no policy that is so global yet that we can't really pause, take the moment and get this right from the standpoint of making sure that that foundational data that is publicly accessible, that is harmonized, etc., is available. And some resources for folks who want to learn more about this. American Wood Council, we own and manage industry-wide environmental product declarations for a number of wood products that can be found on our website. If you are on a design team and are curious about, well, what if we used wood instead of other materials for our project, Woodworks provides that service for free and will work with your design team to essentially take that whole building life cycle approach, and they look at the stored carbon. So you can give them your existing plans and specs, and they can make some changes for you at no cost to see what your building would look like from an environmental footprint standpoint if you used wood products, which organically are low in embodied carbon and naturally store carbon. And finally, more resources about wood products in general and their carbon benefits can be found at Think Wood. So there really is quite a breadth of resource available to you on the market to learn more. And of course, we're always open to questions and thoughts. And with that, I will open it up to questions.
So I know I saw one question, and let's see, WBLCA, Wood Building Life Cycle Analysis, typically use industry-wide EPDs. How can product-specific EPDs be brought into WBLCA models to get to designs that are truly better rather than based on average data?
I think it's important to note that industry-wide EPDs are in fact quite robust. So questions that you'd want to ask related to industry-wide EPDs are they statistically significant? So because they don't necessarily because an industry-wide EPD does not necessarily go to a manufacturer, it still can be to the manufacturer level. It still is very likely representative. And so I encourage all levels of EPD to be recognized as robust, but those are questions that you can ask. And that gets back, quite frankly, into some of the rules of the game. So that we don't have in the Wild West. So when you're looking at policy solutions and policy opportunities, it's, do you need X, does an industry-wide EPD need to represent X% of an industry in a particular region? Those are questions that still don't yet have answers. And so as we look at kind of slowing down from the whole build, from the policy, let's just do a buy clean or build clean even at this point, and making sure that we're getting the data and the infrastructure right, that is a really important question that has been raised with regard to the rules of the game. But in the interim, the industry-wide EPDs are very strong and representative.
Thanks for stepping in there, Marcy. I apologize for my technical difficulties earlier. And thank you, Rachel, for that. So other question, we're getting questions coming in, so I'll just keep rolling. The first one is, how are the goals for decarbonization established? I think at one point you cited a 50% statistic from a benchmark.
Yeah, so those are federal government, federal policy goals. They're established through federal venues. There are goals that are, and they're often rooted in larger international efforts like IPCC, what that really set the framework for what reductions do we need to see in order not to have catastrophic impacts. So IPCC is where a lot of current national goals can be traced back to, but a lot of it is rooted in policymakers and their dialogue. So, but when you look back to kind of source data, IPCC is where you really get the foundational information on reduction needs that are essential to avoid, you know, we're already starting to see some of the impacts, but more catastrophic impacts.
Mm-hmm. All right. Here's a question, and this is a question I have asked as a structural engineer often. We've got an attendee who's a structural engineer, and they've been waiting a long time for a good carbon comparison between steel, concrete, and wood. Is there an answer out there? What tools or what resources would be available to structural engineers or any building professional if they're trying to compare, like we talked about, different materials?
Yeah, so that's a question I would definitely say Woodworks has a lot of that data, but when we get into some of the challenges around inconsistency around EPDs and their scopes, and inconsistencies currently in existing tools around how whole building LCAs are conducted, from the apples to apples, that's one of the challenges that, you know, I've articulated that we're facing, is we don't have a way currently without those rules of the game on a policy level to really do apples to apples consistently. So it's a great question, and it's one that the steps that were outlined in this presentation hopefully will help answer. You know, let's get all of the raw data pulled in. Let's make sure that we have public accessibility to those data platforms. Let's get methodologies for whole building LCA locked in, and then let's move forward with those rules of the game. As an interim step, however, Woodworks has developed their own calculator that does help to do that. So a free resource.
Absolutely. And Woodworks is a great resource that we work very closely with on a lot of issues. All right. Here we go. Okay, here's a question. Can you discuss a little bit more the difference between an EPD and contrast it with a whole building life cycle analysis?
Yeah, so an EPD looks only at a product, and it is defined, how it looks at that product is defined by ISO 21930. It's a very regimented approach to looking at a product's environmental impacts. Whole building LCA allows you to essentially say, what if I do this instead? What will the carbon and environmental impact of my whole building look like? So EPDs are a component of whole building LCA in that they're utilizing a lot of that data from an EPD to get at the whole building numbers. But what you're able to do then is swap materials and among different material categories. So instead of just looking at what is the best pen, you can say, am I better off using a pencil or a piece of chalk? What's really the best holistically for my building? So that's really, they're part of the same story, and they're required. There should be integration for sure. It's essentially the steps that are being taken on a policy level is that whole building should come first, because it allows you to answer the question from the environmental standpoint, is a pen, a pencil, a piece of chalk, or a watercolor paint better? And again, we're looking at this from a purely, and that's why I'm using pens and pencils instead of building materials. Every building material right now needs to be looking at its environmental impacts. 100% of us, there isn't one immune. And so I am not here to poo-poo another material. I'm here simply to say we need to make sure that we get the math right and that we get the methodological approach right, or we're not going to see maximize decarbonization, we're going to see decarbonization of materials, not necessarily the best option for the holistic need to reduce carbon in the environment.
Mm-hmm. Awesome. That's a great answer. Thank you. Here's a question. I think this one's probably more of an opinion, but what is the best way to accelerate change on this topic? Would you say it's through federal legislation, building codes, or perhaps some other approach?
I think that the private sector already recognizes the need and the opportunity to really put the foot down on addressing climate change and the challenges it faces in the built environment. I don't know that regulation is the first answer. I think, again, as I outlined in my presentation, where the federal government has a key role to play is in A, data collection, harmonization, B, benchmark data for all the stuff that they already have, making it public and pulling it together through the library of buildings, and C, the rules of the game. So there are a lot of tools on the market currently, that doesn't need to be a role of the government to run whole building LCAs. There are a lot of very good, robust tools who are doing exceptional work on addressing these very questions. The challenge that we see isn't in that they exist. They're doing a stupendous job of what they're doing. It's the inconsistency among. And so where the federal government has a role to play is to really push policy through establishment of rules of the game so that we have that consistency. I think, and then, incentives, there are ways that I think there can be incentives at a policy level for utilization of, if a building stores X amount of carbon, and, from this, I'll use wood products, and because it is the case in the US, our forest stocks are actually increasing and have been for many decades. If you're using a product that stores carbon, and you can verify through data that it's coming from a source that is being maintained, so you're not leaking, it's not coming from one place causing damage elsewhere and creating a benefit for you, but you're actually, which again is the case in the US, and for wood products, there are incentives that can really move forward. And quite frankly, I think A&E firms, there's a beauty from the standpoint, there's a beauty in some of these solutions, a very aesthetic beauty to some of these solutions. So you look at low embodied carbon, you're looking at a really energy efficient green buildings, which aesthetically are often quite pleasing too. So I think, architects want to design hopefully beautiful buildings, and I think the private sector can really run and wants to run with it. They want to make sure that they're doing the right thing, and that's where I think some foundational policy would be helpful.
Awesome. All right. Here's a question. In your opinion, what is the best or most comprehensive whole building LCA methodology out there? Or alternatively, which would you like to see established as the standard methodology?
Well, I am not here to pick favorites. And as I have said several times, AWC really does actually support robust growth in the realm of tools and businesses who are out there conducting whole building life cycle assessments. I think that when we get to rules of the game is the question that we need to come together. I have opinions, I'm not going to share them. I think that what I would rather have is an outcome that involves the perspectives of multiple parts of this sector, multiple building materials at the same table, really working together to create those rules of the game. And that, I think, will define the methodology that the most that most of us can get behind. And the tools can be, they're IT. Tools are simply technology, right? That are utilizing data to produce numbers. IT solutions can always be modified. So getting that fundamental methodological approach harmonized with input from multiple stakeholders, I think, is my favorite approach. So I'm not really answering that question because I am not going to pick a favorite. But my favorite would be a collaborative approach to establishing rules of the game.
No, absolutely. That's a very, very good and very descriptive answer. All right, here's a good one. What are the challenges of having LCA Commons be more readily adopted by the tools? Is the database still in development, or is it complete and just awaiting more widespread adoption?
That is a fabulous question. In my mind, one of the biggest challenges is it's not being used as widely as it could and should be. And part of that is because right now it's being funded and the oversight is through an MOU without adequate or any funding. It's folks at these three agencies engaged in the MOU who are using their own existing resources to make sure that it runs. So what we really need for the LCA Commons is a quarterback agency. You know, from a wood product standpoint, I'd love to say it's USDA, but this needs to be unbiased. And so DOE seems to be a very logical choice as essentially a quarterback for pulling data in, working with different sectors, articulating what needs to be input, and then educating, working with A&E firms or with the tools, on how they can pull that data into their systems. So to me, I think one of the biggest challenges or the biggest challenges are A, lack of a single point of contact, B, inadequate funding for that single point of contact, and B, because there is an A and B, and C, because there is an A and B, an inability for the outreach that's necessary to really get that up and running. So hopefully we see that change.
All right. Well, here's a question that I actually was thinking of as well. I'm so glad our learners and I are all on the same page, and then I don't have to bother Rachel with these questions later. How does the LEED rating system fit into this discussion? Does LEED recognize LCAs or EPDs? And I guess I would expand that question to maybe some other green rating systems that are out there. I know LEED is probably the biggest name in the game, but there are some others.
Yeah, I mean, like I mentioned earlier, LEED actually does give a point for whole building life cycle assessment. Green Globes also recognizes whole building life cycle assessment and is starting to look at how stored carbon can be recognized in the built environment. So the Green Building Standards ASHRAE 189.1, another green building standard, reference standard, is looking at how it can address embodied carbon as well. So the Green Building Standards, I think they get it. They understand, all of them, that whole building life cycle assessment is a critical component of really kind of maximizing that decarbonization. Here again, we get into the methodological inconsistency and the need for rules of the game. So once those rules of the game are established, it won't matter what system, policy, standard, etc. There will be bounds within which these whole building LCAs should be conducted, and therefore consistency in outputs. But yeah, green building organizations have been keen on this for quite some time.
Excellent.
And it's a great question.
Another question. That was a really good question. Does whole building LCA include energy and carbon for operation and maintenance for the life of the building? So, you know, certain elements of the building might need to be replaced over the life of the building. Is that included as well as, you know, the operational energy?
Well, right now, as I talked about before, a lot of whole building LCA focuses on core and shell. And it essentially, in that kind of small but mighty graphic that I showed in the first several slides of ISO's kind of path, the O&M phase is generally not included. Is there opportunity? Absolutely. What are we missing again? The rules of the game. But right now, I think from just a construction standpoint, core and shell is, and getting really consistent on how we address that is going to be huge, just to make sure that the embodied emissions in the specified materials are maximized. The reductions are maximized. When you get into that O&M phase, that would also be the same phase that you would look at stored carbon and any kind of benefits that the materials in that construction phase might have throughout the life of the building. If you're keeping X tons of CO2 or CO2 equivalent out of the atmosphere for a building that lasts, you know, on average 90 years, how does that get recognized? That would be in that same kind of window. But right now, I think where we're looking at, because again, baby steps to the right answer, is core and shell would be, we could get core and shell assessed at whole building LCA at the design phase, we'd be in a good spot.
For sure. Here's a question on how can existing working professionals be exposed to and become more proficient in using these whole building LCA tools? Do you have any additional educational resources you might want to offer to folks, Rachel?
Absolutely. So I think that right now, a good spot for familiarizing yourself, if you're an A&E firm and really wanting to kind of dive in, I would reach out to Woodworks first and foremost. I come to this with a bit of a bias. I am at American Wood Council, and our story is a really good one, but they do have the math to support it, and they work on the output end with all of the existing, or with most of the existing tools. There are tools coming up weekly, so I can't say all, but they are very keyed into helping design teams at the interface with all of these tools. So that would be, to me, my first stop if you're wanting to dive in more deeply and understand how to enter various inputs in a way that is accurate so that your output is also accurate. You're also welcome to stay in touch with American Wood Council. We also work very closely with all of these tools. They are, excuse me, talking for an hour is a lot of talking. They are very open and gracious. They want to do the right thing. They want to get this right. They want to have the right data. So until we can really move LCA Commons into a place where it is the common source, they're left to try and source the data on their own. And I think that that is honestly one of the biggest issues from the standpoint of that lack of consistency. So if we can get LCA Commons up and running, then we work with all of these tools to give them that foundational data. Now it makes our life simpler too, because we can give all of our data to LCA Commons, who can then feed it into the tools that exist today. Great. And that might exist tomorrow.
Yeah. Oh, here's a really good question. And I know we did a webinar on this last year, so I know that it's certainly possible to talk for a long time on this topic, but maybe, Rachel, you can give us a Twitter-friendly answer, let's say, short and to the point. What factors typically go into an EPD? Is it just measuring carbon, or are there other metrics that are quantified and measured in an EPD?
Absolutely not just carbon. We're focused on carbon in this webinar because a lot of policy is focused on carbon reductions through utilization of EPDs. But EPDs also look at water intensity and energy as part of the carbon. They look at the whole environmental footprint, and the breadth of that really is defined in what's called a product category rule. So what we can do after this is, Lori, let's maybe send out the link to the EPD webinar, because Absolutely. It can be a very long conversation, but the haiku version is no, carbon is not the only thing that is assessed. it's looking at environmental impacts holistically.
Excellent. All right. Oh, here's I know this has been a hot topic in the past. Carbon taxation. I know other parts of the world use it. Is that something that is seen as a potential solution in the U.S. Or just any thoughts on that, Rachel?
I am going to keep my focus today. That's a whole different policy track that would likely involve a panel. And I'm going to say today, let's table that, but let's also maybe put that on the queue for a future potential webinar. It's an entirely different track to me, where there might be financial incentives that relate specifically to today's presentation, is looking at policies that incentivize, through a tax break of some sort, specification of materials that not only are low in embodied carbon, but that store carbon as well.
Excellent. All right. Well, I think our rate of questions coming in have slowed. So, and we are approaching the top of the hour. So, Marcy, while you're going ahead and taking the screen back to close us out, I will just express my thanks and gratitude to Rachel for a really great presentation. I know I learned a lot today. I hope everyone else did.
Thank you. As Lori said, thank you, Rachel, for a great presentation. Just a couple quick slides. Rachel talked about Woodworks being a great resource. We have the slide for them. If you want to get in touch with them, you can visit their website, woodworks.org/project-assistance. And thank you very much for being here today. Have a wonderful day.